Thanks. So I'm here to talk about NextRoll, how we use AWS Batch, what kind of benefit we got from Batch, and what were the challenges we had with Batch, and a little bit about our contribution too. So NextRoll is a marketing and advertisement company. We have about 37,000 brands using our platform for marketing and digital advertisement. For these 37,000 brands, we have built 1.2 shopper profiles. Every day, our machine learning system does 80 billion different predictions. I should emphasize that most AI system doesn't do 80 billion predictions in their lifetime. We do that every day. Through our supply network, we connect our customers to 500 different suppliers for internet advertisement. Just one of them is Google Ads. And now I want to talk a little bit about customers. The first set of our customers are direct-to-consumer companies like students.com, Wix.com, and they're looking for individuals. They're targeting individuals to buy their product or services. The next set of our customers are B2B companies, like companies like PagerDuty that are looking for other IT companies to sell their services. Last set of our customers are the ones that are selling our platform, using our platform to serve their customers. So now that we have a little bit of context about NextRoll and what it does, let's see why we are using AWS Batch. So the amount of data that we generate using marketing is just so huge, we can't use our own laptop. Unless somebody has a really, really big laptop, we need to use cloud. Now I have a question for you guys in the audience. What do you think is this number?
Cost per month.
Cost per month? That's good. Is there any other guesses? All right, this is how much we save using Batch and Spot Market. So if we were not using Batch, our deal with AWS was $5 million more. Like the teams that are using Batch in a company spend like $1 million a year. And if we were not using Batch and we were provisioning EC2 instances and running our jobs on the cloud, we would spend $5 million. And I'm going to share with you how we're doing that. Besides cloud processing and cost saving, there are other reasons to use Batch too. The first one is freedom of stack. We have jobs using Python, Golang, C++. We have jobs using Rust. We have jobs using Haskell in production right now. As long as you can package your content and your code in Docker container, you can use them in Batch. The other reason is the special way we have for processing data. We have some in-house file formats, and because we want to order the data in the file formats in a way that's being easier to process, like the data for same entity in TrailDB are next together, which makes it easier and faster to process, and Bash let us use our own file formats. Like comparing to Hadoop or Spark, which have their own file formats, we can use our own in-house formats. The other reason is ease of deployment. The deployment with Batch is as easy as Docker build, Docker push, and that's all. As long as the image is available in ECR, you can use them in Batch. 2 years ago, my colleague Miko Yola did very similar talk in reInvent. At the time, Batch was only out 6 months. We had 2 teams using Batch, launching about 2 million jobs, provisioning 300,000 instances every year. Now, after 2 years, we have 16 teams running about 11 million jobs, provisioning more than 3 million instances in 2019 alone. That shows the growth of NextRoll in the past 2 years. It also shows the scaling of Batch. And since in our company, teams are running like a startup, they have an objective and they can use any technology they want in the stack to accomplish those goals. The fact that these teams choose Batch to accomplish their goals shows that Batch was promising technology for them. So now let's see how we are using Batch. So for us, processing starts with Jenkins. Jenkins downloads the source code from GitHub. It builds the Docker image and it pushes to ECR. We also have some containers running on ECS, which does the scheduling and dependency control for us. So when the scheduler says, send the job to Luigi, Luigi check the dependencies, make sure the job did not run before. If all the criteria is met, is going to send the job to Batch. Batch will download the Docker image from ECR and will launch some instances or going to reuse some instances to run those jobs. After the jobs are running, our software Batchy is going to monitor the jobs. I'm going to talk more about Batchy in the coming slides. Now that I show how we run one job, let's see how we do a real-time application with Batch. One of the use cases we have is to convert data from CSV to ShareDB or other file formats. So consider we have some CSVs in the cloud, in this case S3. The first job that we run on Batch is Planner. Planner is going to check how many CSVs are out there, how many events each CSV has, and split them to the splits that are going to go to our mapper job, which is Baker in this context. So for each split, we're going to run one Baker job on Batch. When Bakers are done, they save the output on S3. When the outputs are available on S3, the reduced jobs are going to run on Batch. They're going to reduce the output from Baker and save and shard them on the output. So the beauty of this schema is it scales with data itself. One day we may only have 10 Bakers running on production, and one day we may have thousands of them. And the whole cluster is scalable. I want to pause here to see if anybody has a question. It's supposed to be an interactive session. We can continue. All right. So let's see what the purpose of the jobs we run on Batch. We have 80 billion events every day. Each event is about kilobytes of data. And it adds up to 80 terabytes of data. So for some applications like attribution, we have 500,000 conversions every day from our customer websites, and each conversion is like sales or something meaningful that happens on customer's website. And we need to look back 30 days to see what event or events caused that conversion to happen. For these applications, we need to process 30 days of data, 80 terabytes each. It adds up to 2 petabytes of data that needs to be processed. And Batch is scalable for us in that sense. The other reason is machine learning. As Steve mentioned, other companies are doing that too. We update our model on Batch every day with fresh data. We feed them to some jobs on Batch to update the machine learning model. And I think it's a great use case for Batch too. So in summary, Batch is good for periodic tasks, data pipelines. It's also good when you want your processing scale with the data itself. It's flexible in stack, so you can use whatever you like. The other use case for us is different instance types. Some of our queues are using optimal, which is going to provision the smallest instance possible to run that job. Some of those instances, some of the queues or compute environments are using a specific instance type. Like one queue is using X116X large, which has like 1 terabyte of memory for some big reduced jobs. Maybe in few words, I can say Batch is a great tool for orchestration. When you want to orchestrate some nodes, what happens in those nodes is up to you. But Batch came with its own set of challenges for us. The first challenge was monitoring. We are submitting millions of jobs to Batch, and finding a job that fails or did not run properly or did not do what it's supposed to do is finding a needle haystack. We developed our own software, Batchy, to help us do the monitoring. The next challenge is out-of-spot instances. It seems Batch developed some new products to address that concern. But what happens for us is some compute environments are using specific instance types. And when that instance type is not available on the spot market, the queue is just going to be pending. So what we need to do in this situation, we need to go and hunt different instance types that the stock market has enough pool of them to serve our need. It's a really challenging process, it's trial and error. We don't have any visibility to spot market pool. but fortunately it doesn't happen often, maybe like once every 3 months. Still a problem. The other challenge is disk cleanup. So usually when you submit a job on batch provision instance for you, deploy a Docker image, run that Docker container. When Docker container is finished, terminate that instance. For us, the situation is different because we submit so many jobs, an instance may be available and run so many jobs. When that happens and the last job did not do this cleanup, the job after that may fail. What we did is we have our own AMI that does aggressive disk cleaning. It removes all dangling Docker images, unused Docker volumes to make sure the next job can run. That was our workaround. The next topic is a little bit controversial. So orchestration in batch happens in low level. When you're comparing it to Hadoop or Spark or SageMaker, those frameworks, you write a little bit of piece of code and those frameworks scale it for you. In batch, it's different. You're supposed to handle all the glue logic yourself. This might be an advantage for some people because they might like to be in control. But for us, I think it's a challenge because after a while, we end up having a lot of boilerplate code to handle this glue logic. The last thing I have here is manage compute environments. I have it here, but it's actually compute environments. So for managed compute environments, batch scale the queue for us automatically. What happens is when you submit so many jobs, batch is going to set the desired vCPUs and make sure the underlying queue expands. In our experience, the compute environment doesn't catch up quickly. And what we did is we added some logic to batch Apache. Every minute, it's going to calculate the number of vCPUs required to run all the jobs, and it set the minimum vCPU to compute environment to work around that challenge. The last one, which actually, I don't have it here, but somebody asked the question yesterday, which I think is useful, is another challenge we have with batch is the jobs in batch doesn't have timeout. So if the job doesn't do something properly or does not finish for any reason, it's just going to hang around. We added another logic to batch Apache to add timeout to jobs. So batch Apache is going to kill the jobs if they do not finish on the time specified. So I keep talking about batch Apache, and this is our contribution, and I wanted to talk more about it. It's a product of Hack Week. 2 years ago, after 6 months that batch was out, one team of engineers decided to use that Hack Week to make a software to help their own life, make their own life easier. Lorenzo came up with the idea, and Miko came up with the name. Miko actually open sourced it last year, so now it's available to be forked. We appreciate any contribution to this project. We're using it for monitoring, for reviewing the logs, for searching the jobs. We're using it for cost estimation, and we also use the SQL database in the past. I'm going to go over each topic now. So this is a snapshot of batch console. As you see, each line is the queue, and you can see number of jobs submitted, runnable, failed on each queue. If you click on any number, like on 137 number, you're going to see the jobs that are running on that production queue. What it doesn't give you is showing what happens generally on that queue. Like for example, consider you have a map reduce job with 50 mappers and 50 reducers, and you want to see the whole thing in one view. Batch Apache provides a searching option, and you can constrain the queue. You can constrain the queue and also the status of the jobs, and it will list all of those jobs that you're interested in one view. Some of them might fail, some of them will succeed, some of them are still running, and you can see what's going on. You can see the whole picture. The other challenge we have with batch is logging. So batch recently added a feature, I think it was 2019, that you can enter the job ID and you can see the logs for that job. It provides a CloudWatch link that you can see the logs. The challenge for us is when you scroll up, And when your job has so many output lines, like thousands of lines, when you scroll up, it takes a while to load, and you can't see the whole log. Batch UI is like more developer-friendly version. It loads all the logs in one text box, so you can go from start to end, see what happens in the job, and start your troubleshooting process. It also shows the command line and all the information it has about the job in just one view. The other problem we have with Batch console is searching for the jobs. This feature added recently that you can enter your job ID and get your job information, but how you're supposed to have the job ID is like a long UUID number. I guess you can have additional system that have the information of your job and the job ID and look it up there. Batch on the other hand, let you search for the job. So here I'm searching GDPR, a very popular term in the industry, and it shows, it lists all the jobs that has GDPR, in this case, in the command line. It searches both name and command line. And in this case, all of them are running at this time. The other view that Batch provides, I couldn't find any alternative in Batch provides, I couldn't find any alternative in AWS console, is showing you what happened on the queue over time. In this view, I'm putting the failed jobs on one queue on 1 week past October 16, and you can see there was a spike of failing jobs on October 16. And when we see this view, we can go and find what was going on October 16, why we had so many failed jobs. We're using it for when the estimated cost of the queue does not match of the actual cost, or when something happens in production. The other benefit we get with Batch is its SQL database. It stores all the data it gets from Batch APIs to a Postgres database. And we use this a lot. One of the use cases, for example, is in Batch, in Cost Explorer, you can tag your queues and see how much you spend with each queue. What it does not provide, though, is you can't find out what is the most expensive job you're running on Batch. We use Batch to aggregate data for all the jobs and find out the most expensive job to go after that job and make that queue cheaper. Now I'm going to hand it over to Steve back to talk about.
All right, great, thank you. Obviously, the best things about my